Hello, 6th graders. Welcome to 17.4. Today we're going to talk about properties of circles. On your note sheet in front of you, our objective for today is to identify parts of a circle and to find the central angle measures. So today we're going to look at what makes up a circle, what are the different parts to it, how do we label them, and then how do we find angle measures in part of that central part of our circle. Remember that as we go, feel free to pause, rewind what you need to do, what best suits you. Alright, so here's our first vocab word, a circle, right? We know what a circle is. A circle is the set of all points in a plane that are the same distance from a given point, and that middle point is, we call that the center of a circle. Okay, so there's our definition of a circle, the set of all points in a plane that are the same distance from a given point. And that given point in the middle, that where the distance is measured from, is called the center of a circle. All right, so here's just a side note. You don't have to write down this bottom portion here, but a circle is named by its center. So for example, it says, if point A is the point in the middle of a circle, then we call that circle A. There are different names for parts of a circle. We have special names that we give them, how we label them, but we name a circle by its middle point. All right, so let's take a picture of a circle here, and let's break it down into the different types of parts that make it up. Our first item here, so on your notes, the picture here that has this little circle that's highlighted on the outside, by the arrow, go ahead and up in that left-hand corner there, this is called an arc. What is an arc? An arc is this part of the circle, and it is named by its endpoints. So an arc is only part of the circle. It's part of around the outside. The next item for you to identify, so find this picture there, right under there with the arrow. Next to the arrow, go ahead and write, this is called the radius. The radius is a line segment, so we talked about that in 17.1, whose endpoints are the circle of the center and then any point around the outside of the center. So it's halfway of the circle. So from the middle of the circle to the outside of that circle, that segment is called a radius. Then we have what's called a diameter. The diameter is a line segment. It passes through the center of the circle, and the endpoints then lie on the outside of the circle. So the radius is half from the middle to the outside. The diameter is full. It's all the way from one side of the circle to the other. You'll also notice that the radius, since that's only half, that is half the diameter. And then the last part of our circle is called a chord. So a chord is a line segment whose endpoints are any 2 points on a circle. You'll notice here it doesn't have to go through the middle. It can, but it doesn't have to. So a chord is a segment that any endpoints are 2 points on the circle. So from one side to another side of a circle, it can go through the middle, but it doesn't have to. That's called a chord. All right, now we're going to identify some parts of the circle. So it says, name the parts of circle M. We call it circle M because that's the center point. Look at this crazy word over here, the radii. Radii is plural for the radius. So we want to name all of the radius, the radii, in this circle. Now, if we look back to our definition, the definition says it goes from the center of the circle to the outside, to any point on the outside is called a radius. All right, so let's take a look at our answers here. How do we name a radius? All right, so since we have M as our center, we're going to start from M, and we are going to go to every segment that goes on the outside. So here we have segment MN. This is a radius from the middle point to a point on the outside. And notice the label we put on top here. That label is a line segment. That's what we're asking for. So that should be just a line. No arrows, but that's what we name it. Segment MN. Segment MR, so from M to R, is also a radius. Segment MQ is a radius. And segment MO is a radius. So we start from the middle and we work our way out. So all the radius, the radii, are from the middle point to any point on the outside. Let's look at diameters. From our definition, we know our diameter goes from one side of the circle to the other, and it has to go through the middle. So diameter has to go through the middle. So we have to go through point M. So from one side to another, that's how we're going to label it. So this is line segment NR. So it goes through point M. We label it by its endpoints. Segment NR is a diameter. You can also reverse this if you'd like and say segment RN. That's another way you could name it. Segment QO, or if you reverse it, OQ, right? That segment is also a diameter. So there's two diameters in this picture. A chord. A chord is any part of the circle connected from one side to another. It does not have to go through the middle. So NR, take a look here. NR, oh, but wait, wasn't that a diameter? It was. A diameter is also a chord. It connects one side of the circle to the other. It just happens to go through the middle. Segment QO then is a chord. Oh yeah, that's another diameter. Diameters are chords also. So you notice that our first two answers are the same. But there are more chords. Another chord is Q to N. If you notice Q to N here, it does not go through the middle point, but that's okay. A chord does not have to go through the middle. You could reverse it and say segment NQ. And then the last one here is segment NP or segment PN. So this chord right here. So there's 4 chords on that item there. All right, so here's another example. Let's just take a look. You don't need to write this down, but let's just take a look and see what's happening here. Name the parts of the circle, and we have circle G here. So our radius, we're looking from G to the outside. So segment GB, segment GA, segment GF, and segment GD. All right, so those are all radius, radii. Diameters have to go from one side to the other through point G. It has to touch point G. So we have diameter BF, or we could say FB, right? And we have segments above it. You've got to label it as a segment. And segment AD. What are the chords? All right, well, chords, our diameters for sure need to be in the list. So you notice on the bottom here, segment BF and segment AD are there. But there are more. So we have segment AH. So this part right here is a chord. Segment AB and segment CE. All right, so there's another example just to get an idea of how to write those items.
Hey there, class. This is Mr. Hughes taking over for Mrs. Peterson. I know she did a wonderful job at the beginning of this lesson in 17.4 in properties of circles. I'm going to talk about a couple vocabulary terms, and the first one's going to be a central angle. Central angle of a circle is the angle formed by 2 radii. I know Mrs. Peterson talked about the radius of a circle being from the center out to the edge. And that central angle is formed by 2 of these radii. And you can see the identification of that central angle on your diagram right there. If you want to draw that somewhere either in the definition box or underneath your vocabulary word, that would be outstanding. So the central angle is just simply the angle of that's formed by 2 radii. And then we have a sector. And a sector of a circle is part of the circle enclosed by 2 radii and an arc connecting them. So really what it is, if you think about it, it's a piece of pie, okay? Or a piece of pizza. If you cut a pizza in coming across in the diameter, you have a triangular shape with an arc, obviously, piece of pizza or piece of pie or whatever else you want to do. How about a chocolate chip cookie? Those are my favorite, by the way, if you want to bring me one. Anyway, the sector is one of those sections. So in this diagram here, we actually have 4 sectors, okay, that are basically cut out of a circle. The sum of the measures of all of these central angles in a circle is 360 degrees, because we know that a circle is 360 degrees, and so are all of these angles that measure up to be 360 degrees. So we're going to do a couple problem solving here, and our first problem says a circle graph shows the results of a survey about favorite types of muffins. Find the central angle measure of the sector that shows the percent of people whose favorite type of muffin is blueberry. So as you can see on this diagram, this pie chart here, you have blueberry represented in blue, and that's 40% of the students here like the blueberry muffin. So what we're going to do is we are going to find out what the central angle measure is of that particular pie chart. The answer is the measure of the central angle that represents the blueberry. There's a couple things that are important to understand, that the percent of people whose favorite muffin is blueberry is 40%. And we also know that all of the central angles together equal 360 degrees. So 40% of the 360 degrees is going to be blueberry muffins. To solve this, we're just simply going to take 40% of 360. In other words, we're going to take, in our calculators, we're going to take 0.40, that's 40%, times 360. When you do that in your calculator, 0.40 times 360, you're going to get 144 degrees. And that central angle of the sector is 144 degrees. If we look back, 40% sector is less than half of the graph, and 144 is less than half of 360, so it's a reasonable answer. We're going to try another one. You don't have to write this one down, but just please follow along as we go through this. The central graph shows the results of a survey about the favorite types of muffins again, and this time we're going to find out what the central angle is of the banana nut muffin. And the banana nut muffin is represented in the green, and that's 35%. So you should be thinking, okay, 35% of the 360 degrees is banana nut. So we're going to take 35% of 360, so we're going to take the decimal 35%, 0.35 or 35 hundredths, times 360 degrees, and we're going to get 126 degrees. So we can say that the central angle of the banana nut muffin is 126 degrees. If we look back, we have the 35% being less than half, 126 is less than half, so we're good. All right, ladies and gentlemen, your assignment for 17.4 is to complete the worksheet. I hope it all goes well. Have a great day.